Our fast-changing cities. Compact, complex, and unsustainable. Yet, with manual and legacy management systems. Imagine the game-changing technology for sustainability. We deliver real-time, cost-effective, and predictive solutions.
We empower our built infrastructure for the robust city management. We are here to make our city safer, greener, and smarter.
More than 100 customers. We are RaSpect.
Hello everybody and welcome to this latest video discussion in the RICS Tech Partner Series. My name is Andrew Knight. I've been with RICS for nearly 12 years now, and I work in the knowledge and practice area of the organisation, looking at the impact of data and technology right across the built and natural environment. And with 110,000 members working worldwide, right across the property life cycle through land, development, planning, construction, brokerage, building management, building surveying, building operation, finance, valuation, and indeed working across all the major asset types of land itself, residential, commercial, alternative assets and infrastructure. Clearly data and technology is having a huge and positive impact on our profession in every dimension. And I'm really pleased today to have Dhanada joining me from RaSpect AI. So please do join me, Dhanada. And before we get into the technology side, Dhanada, it'd be great to get a bit of background on your backstory and then the origin story of RaSpect and what you're doing with RaSpect.
Sure, Andrew. Thank you again. My name is Dhanada Mishra. I'm a civil engineer. I got my PhD in civil engineering from University of Michigan way back in 1995. And since then, I've been working both in industry as well as in academia. And for last couple of years, I've been with RaSpect. So RaSpect AI is a Hong Kong-based startup founded in 2017 by Harris Sun. Harris is a computer science graduate of Hong Kong University. He started out with Cathay Pacific with the innovation group, where he brought in drone inspection of aircraft fuselage as a substitute to manual inspection, and to detect defects in the aircraft body. And this involved, of course, taking images and infrared data that need to be processed automatically using computer software, which he developed. So this approach was then he thought of bringing it to the building sector. In Hong Kong, particularly, as you know, it's the world capital of skyscrapers, a lot of tall buildings, very closely spaced, and inspection of those buildings present specific challenges in the conventional approach. And drone inspection has come to be a game changer over the last 4 or 5 years. And alongside the drone inspection, the AI technology, which automates the data processing and defect detection in buildings, has really come a long way over this time. And so RaSpect is the market leader now in Hong Kong and poised to go outside and go global with its technology. Yeah.
Thanks, that's great. What are the particular benefits of using AI, Dhanada, in building inspection and the way you're doing it?
Yeah, conventionally, I started out as a, you can say structural investigator, inspector, where I would go and inspect structures of various kinds, be buildings or plants or towers or dams or bridges. Now, conventionally, as you know, you go to the field, you look at the structure, you try to identify the critical areas, you look for obvious defects, and you try to document them, and then you carry out non-destructive testing very often to collect samples or collect data, and then you take that all back to the laboratory for further testing, and then you write up your report on the condition of the structure of the building. Now, this approach, of course, involves an expert, subject expert, and involves a lot of advanced technology. It often takes time. It often involves climbing up on structures, on scaffolding, or tall structures manually on even ladders and so on. So it can be quite unsafe. Then the data and its interpretation is often subjective, depending on the person's background and experience and so on. So with all of these, shortcomings, I think our field has been quite conservative and quite slow to change. But with the advent of very powerful drones, it became possible that instead of doing physical and manual inspection, you could actually do a much better job with the drones. And but the flip side of that is you end up collecting a lot more data compared to what you would collect when you are doing it manually. And therefore, for a typical building, you will end up with hundreds of images, both visual and thermal images, and to go through them and try to find the defects and then document it properly and so on, localize the data so that you know which image belongs to which location on the building. So all of these are pretty tough challenges, which lend themselves very well to an automated computerized procedure, particularly with AI. So that is where AI comes in, which is very good at computer vision based approach, which processes all the data, and it's been trained to look for certain features, certain defects that are typical of the building being inspected, and therefore it shortens the whole process, makes it easier, and saves a lot of effort, and therefore the cost of building and structural inspection. Yeah.
That's great, and it's always wonderful to hear how AI is actually being put into use in that way, in something really, really sort of practical. I mean, are there also any benefits from a sustainability point of view of using this kind of AI-supported approach?
Yeah. The major original motivation for RaSpect to work on this technology was actually structural safety. Cities like Hong Kong or Singapore or even London or New York, they would typically have regulation which requires buildings or any tall structures to be periodically inspected so that there is no safety issues with the facade or the structure surface where something could come loose or fall and hit something and injure somebody or cause damage. So therefore, Hong Kong has a regulation called MBIS, a Mandatory Building Inspection Scheme, which was introduced in 2012. And it requires that any building which is older than 30 years must be inspected once every 7 years, for example. And therefore, a lot of the older buildings, which typically cause around 20 incidents a year, they get subject to this kind of mandatory inspection. And that is where RaSpect's approach using drone and AI became very useful. And all the backlog of inspection, which is very difficult to carry out timely and as and when they become due, using the conventional approach, can now be done in an automated way. But having started from the safety angle, which is obviously very important, what has come to pass is that our approach in technology makes it easier and lowers the cost of inspection. And therefore, these buildings and other infrastructure can be inspected more frequently than before. And therefore, the asset owners and the facility managers have a much better idea about the condition of the buildings, and they can take steps to prevent the defects and other issues to becoming much worse. And therefore, we believe that it adds value in the sense that the building's service life, not only serviceability in terms of its use and value, but its service life itself can be much longer than the design service life, which therefore reduces its carbon footprint and adds to sustainability of our infrastructure. So therefore, increasingly, we are pushing more on this aspect alongside the aspect of making our infrastructure safer.
No, that's very good. And you mentioned facade particularly as some of the kind of building elements that you're inspecting. I mean, what's the range of kind of inspection tasks that you find this approach is good for?
Yeah, so typical condition survey is what we carry out. And as I said, we started out with buildings, building facades, which continues to be our primary technology and service. In Hong Kong, we provide an end-to-end service in the sense that we take up any project where it starts with data collection using drones. We have our own expert in-house drone pilots, and also we have several partners, so we can take up a large number of jobs at the same time. Then after collecting the data, we use our own proprietary cloud-based technology, the software platform, which is called Inspectica, to upload the data, process the data, then the AI model takes over, and then it predicts all the defects, which then have to be reviewed to make sure that they're all correct. And then we generate an automated inspection report, which includes all of the data that's been collected and all of the AI model predictions and the corrections done by experts. And then the report is endorsed by a registered building surveyor or inspector who is authorized to sign off. So the entire workflow is offered in Hong Kong. In overseas markets, we plan to work with partners, local drone service providers, as well as local registered professionals who can look at this data, look at the AI model predictions, not only verify them, clean them, and add their comments, add whatever rectification measures that are required for certain type of defects, and then the report can be signed off by our local partners in overseas markets. Now, we have been using this approach for several other applications other than buildings, because as you can understand, it's fairly generic in the sense it's autonomous data collection, the data processing, and detecting defects or other features using AI, and then report generation. So we have a very interesting big project with Hong Kong government, for example, where we help to detect defective signboards in the Hong Kong streetscape. So this is a particular problem which the government used to handle manually by sending out inspectors who would look at some samples of signboards and identify those that don't agree with the local regulations or pose some kind of danger or risk of safety, and then hand out challenges or tickets. But now we have an automated instrumented vehicle that goes on the street and collects the visual images, which can then be processed on a custom built platform where again AI picks up all the defective signboards, makes the whole process much easier for building department to enforce their regulation here in Hong Kong. So similarly, there are many other use cases for this approach that we have executed several types of inspection projects. Yeah.
So it sounds like, as well as having started with this kind of drone coupled with AI approach, you now have this combination of cloud computing, I guess, to store some of the big data, the AI itself, and I guess that also links back into the fact that you're using the surveyors to help you train that data. So it sounds like you've managed to combine big data, cloud, AI, potentially sort of Internet of Things, I suppose, if you're talking about those kind of remote things. Is that the way you're moving your architecture to?
Yeah, absolutely. So the whole idea from the beginning was how to leverage the best of technology, the latest of technological developments to improve the processes, the workflow of inspection, be it building inspection or infrastructure inspection. It could be a bridge, it could be a dam, it could be a tower. So same approach can be used. We are also, so therefore, like I explained, I mean, cloud computing becomes important because you want to be able to upload your data from wherever you are when you are collecting with drone or with any other means that you are doing that. Then you upload it to the cloud platform so it can be processed and you can access it from anywhere. Then your partners, like you said, the experts, building surveyors, they can also look at it, they can annotate it, they can delete any wrong predictions by the AI or add any predictions that are missed. But in the process, what happens is we keep adding to our database, which has been expert validated, and this expert validated database goes into the model training. So the AI model keeps learning from that and keeps improving. So its accuracy goes up with time. So that is how we collaborate with the experts in the field and try to improve, capture their knowledge and improve our AI model and our platform. Now, regarding the IoT sensors, for example, the Internet of Things approach, what we have started building now is moving on from inspection to more monitoring. We are looking at building operations also. So we have already executed several projects where instead of doing this one-off periodic inspections, we do continuous monitoring of building operations. Now the drone inspection of the building facade, of course, becomes one set of data in this, but it actually includes any operation in the building, be it transportation like lifts and escalators, be it water supply system, be it HVAC system, be it any number of the security system or the indoor air quality. All of these are, as you know, can be measured using wireless sensors, and the data can be collected in real time, and it can again be uploaded to our cloud platform where we have very good visualization and processing tools that can do predictive analytics and basically in many cases try to predict when certain systems, certain equipment or machinery may fail or may require proactive maintenance work so that their life is also extended. So that's the next product. That's a smart building management system that we are also working on at the moment. Yeah.
And you mentioned, Dhanada, some sense of working in other jurisdictions apart from Hong Kong. I mean, what are your plans there? And I guess there might be challenges around perhaps different building pathology and different kind of defects. What's your plan about, deploying this technology outside of Hong Kong?
Yeah, it's last year that we have started moving out of Hong Kong to take up projects outside in other jurisdictions, like you said. And there are some unique challenges that we have faced and overcome in this short period of time. RaSpect obviously has become the #1 company in this field in Hong Kong. And therefore, it was logical for us to explore because Hong Kong, of course, is although it's a very big market with respect to building inspection, given the number of skyscrapers and very high value properties that are located in Hong Kong. But our approach actually, because it is cloud-based, because it's big data analytics, because AI and so on, it is actually quite suitable for a global expansion and to offer it to a wider market. And therefore, it was logical for us. First, we took up some projects in neighboring Shenzhen, for example, in Macau, which were much similar to Hong Kong in many respects, far away. And then we moved to Australia and have successfully executed projects there, where we have taken partners who are themselves building inspectors, and they're very happy to use our platform to process their data that they collect. Now we generally specify the method of collection, the type of data that goes well with our platform, and they're very happy to comply with that. And once the data is on the platform, it's automatically processed, and our partners review the data and they put in their inputs as per the local regulations and local standards and so on. And then the report is generated. And this way of working has worked very well, at least in case of Australia and New Zealand. And just recently, we executed our first project in India, and very actively looking for projects. And we have put in several bids in Singapore, for example, and have several inquiries from Europe. And we have plans to move to Middle East. And my colleague has just moved to Canada, where we have also our initial inquiries, and most likely will be taking up our first project in this quarter. Yeah.
Thanks. And I guess it's interesting, isn't it? Because it really does emphasize how AI needs to work with human beings, because you need those professionals to help you understand the defects and train the system. So it's in no way replacing the surveyor. It really is that positive story of really complementing what they do. I mean, when you reflect back over the progress you've made, what have been some of the biggest challenges, either in terms of technology or process, to reach the point you've reached?
Yeah, there are several major challenges. To start with, AI itself for building inspection is probably one of the more complicated challenges, given the diversity of building types, building facades, whether it's a reinforced concrete building or a cotton wall building or a heritage structure. In Hong Kong, for example, you have all these tiled facade buildings. where the joints in between the tiles can very easily mimic a crack, so the AI could get confused. So there's a lot of challenges in building a robust AI model which can detect a large class of defects, because as you know, in buildings, we have documented at least 60 to 70 different defect classes. So obviously the most common ones all of us are familiar with, like cracks and spalling and delamination and rust and corrosion and these kind of defects. But then there are many others which are lesser known, but you do come across them and you have to cater for them and so on. So it becomes a very large problem that can handle many variables and so on, and therefore it would need a very large data set. And some of the defect types, for example, of building types, you may not have sufficient amount of data yet. As we keep adding to our data set, we find that we have a lot more of, let's say, concrete cracks as opposed to, let's say, sealant problems in cotton wall buildings, which could be hidden up sometimes, not easy to detect or find. So these are challenges with the AI model, but we do keep making progress with more data that we collect. And as we add data from buildings from other parts of the world, then we build other models that may be more specific to a particular building class or building type, and then so on and so forth. So this is an ongoing process and a challenge to be overcome. The second challenge would be the local drone operation regulations, which varies from place to place. And very often it is not only the national policies, but it's the local city policies and restriction zones and the approvals for the drone flights from civil aviation and so on. So this is a problem, of course, we have overcome in Hong Kong. We are very well known here to the civil aviation department. We've got the highest rating for drone flights and so on. So we are able to fly at many places where ordinarily it's very difficult to get permits and so on. But in overseas conditions, we rely on our partners, and they are generally the local drone service providers who are completely familiar with the local rules and regulations, and that is how it has worked out quite well so far. So it's a kind of a joint effort, but every time we move to a new market, we have to study the local situation and understand it fully. There are, of course, many challenges of intercultural. When you're going global, when you're expanding overseas, then abiding for local laws with respect to, for example, data privacy. Or cloud storage of data. So we have to make sure that the data from Australia kind of remains in Australia, even though it's a cloud platform. So we have to work with AWS, for example, who is our cloud storage provider, to make sure that it's partitioned and that those rules and regulations are satisfied. So these are the kind of challenges that we have faced.
Indeed. I mean, you've obviously made huge progress and overcome, as you say, a lot of challenges. What do you think is the overall sort of future prospects and opportunities for this kind of sort of AI robotic inspection of infrastructure? What more do you think that the technology in this approach can bring us?
No, this is a very exciting field, and we are just only at the beginning. And I see a lot of opportunities, and the sky is the limit, literally. And somebody from civil engineering background, like we are an AI software company. I'm the only civil engineering expert, so to say, in the group. But when I first realized how powerful AI can be, and since I had the experience myself of carrying out inspection manually in the old methods, and I know how painful and difficult it can be, time-consuming and unsafe, and so on. This new approach is really a game changer, and I believe that with more and more data and the AI models becoming even more powerful, we should be able to provide technology which makes both condition survey, documentation, and repair and maintenance of not only buildings but all of our built infrastructure in our so-called smart cities or are increasingly urban environments. It becomes much more cost effective, much more efficient, and therefore I think it all really contribute towards that sustainability factor that's so important in this day and age. Yeah.
Yeah, I think that's really worth emphasizing, isn't it? If we can, keep our overall infrastructure more resilient and, as you say, extend its design life, that will have a huge value in terms of saving on replacement, refurbishment, refits. It's a huge issue when we think of a city or a region and think of the amount of built infrastructure. If by only increasing that by 10% of its design life, that's a huge benefit, isn't it? So, well,
Absolutely, I'm very excited about that. In fact, that's what drives me much more. I mean, as much as the safety aspect, but I think sustainability and the carbon footprint and the whole climate crisis that's impending is really the driving motivation for a lot of.
Well, I think you're right. I think technology should never be an end in itself. It's a means to an end, and we always need to focus on the value of what we're doing with data and technology. Well, Dhanada, it's been a fascinating conversation. I really appreciate you taking the time to talk to me today, and I look forward to catching up with you again in the future. But for today, thanks very much.
Thank you so much, Andrew. We are so happy to be RICS tech partner, and through RICS, we hope to reach out to a much larger audience and potential users of our technology. And let's hope it's going to help in the mission that we have. Yeah, thank you so much. And
pleasure, and enjoy the rest of your day.
You too. Thank you.
作為一個測量師咧，我哋做外牆勘察報告嘅時候咧，最難嘅地方咧就係往往用上2-3個星期時間咧嚟到編輯我哋過千張嘅相，或者中間可能要加插一啲圖片嘅時候咧，咁我哋要改動嘅時候咧，亦都係我哋好大嘅困難。咁但係當我用呢個 Inspectica 呢個一站式嘅平台之後咧，我哋發現到咧好方便、好容易咧，我哋就可以 upload 我哋嘅 video 上去，而且呢啲嘅 video 咧，佢就可以係透過 AI 嘅技術咧，自動咧嚟到去製作成一個好全景嘅一個立片圖俾我哋。咁喺個立片圖裏邊咧，我哋好容易、好精準咁樣咧，就將我哋嗰個嘅揾到嘅 defects 咧嚟到 mark 咗上去。咁做完晒呢啲嘢之後咧，我哋就好容易咧，同埋好自動化咁樣嚟咧，就能夠做出一個報告出嚟。咁呢個報告咧就可以擺喺我哋呢個平台上邊咧，唔單止方便我哋測量師嚟到去檢視翻呢個報告，仲更加方便嘅就係話我哋好容易咁樣就攞呢個報告喺個平台上邊咧，向我哋嘅客人嚟到講解呢份嘅報告。呢個報告嘅內容咧，如果係有需要好仔細咁睇到每一個 defect 嘅時候咧，其實我哋就可以直接喺個平台上面咧顯示俾我哋嘅客人睇。 咁有陣時有啲客人會擔心啦，問我哋：喂，咁你影咗啲相翻嚟咧，有陣時會影到啲人樣會點算啊？唔使擔心，呢個 Inspectica 上面嗰個 AI 技術咧係可以自動幫我哋咧遮蓋咗呢啲人樣出嚟，咁所以變咗咧就唔會擔心話有私隱嘅問題啦。咁所以咧整體嚟講咧 ，Inspectica 咧就係我哋一個一站式嘅一個平台，能夠幫我哋儲存好所有嘅報告。亦都能夠將呢啲報告好容易咁樣嚟到向我哋嘅客人去講解，所以咧呢個平台咧係方便咗我哋測量師，亦都方便咗我哋嘅用戶。